Hey folks, welcome to episode number 14 of Unsung Heroes of the Cloud, where today we are joined by Steve Lasker, who is going to walk us through Notary v2 and what that means for the Azure Container Registry. And with that, Steve, welcome to the show.
Well, thank you. Lucky 14. Did you skip 13?
No, we actually had 13, and I think 13 was a very positive episode because our guest joined Microsoft 3 weeks after we spoke to him.
Awesome.
So it was a lucky number 13.
Very cool.
So, Steve, before we jump into the tech itself, we do like to get to know our guests a little. So tell me, what do you like to do when you're not working with containers and container registries?
Well, it's a lot of fun. You're always trying to find some balance to things. I tend to like working with my hands and doing more physical stuff. I work on my house and do various projects, from kitchens and bathrooms to we're now relining the sewer line. So that's always fun. Or just getting out and hiking and being in Seattle, there's mountains, there's lots of water. So I like to say I have a lot of instead of owning a boat, I have friends with boats. So I do a lot of sailing and there's a lot of racing here in Seattle. So that makes it a lot of fun.
So what you said, you do sail racing?
Yeah, it's, sailing is one thing to be out on the water and it's a lot of fun. But when you start racing with each other, there's a pretty competitive number of competitive fleets that are in the Seattle area. So you get out on some boats and do a lot of racing on pretty much 5 days a week during the summer and, and a couple of times a month in the winter. So.
Oh, wow. That sounds pretty amazing. And do you sail in the ocean or in one of the greater lakes in Seattle?
It's in Puget Sound. So it's protected. It is the ocean. It is salt water, but it is very well protected before it gets up to the Straits of Juan de Fuca. So there's good winds and there's been some pretty good storms on occasion. And
yeah,
it keeps us busy.
Yes, I can definitely imagine. That sounds like a fun hobby to have, like sailing on the water and just using the wind to propel you forward. Sounds fun.
Yeah, it's a very thought process, physical, because you have to tune all the sails and understand the strategy with other people racing. There's currents. There's just weather changing. There's crew. There's just it's a lot of fun.
And is sailing a solo sport, or do you do that in a team?
There are people that do solo sailing, which is pretty amazing when you think about all the things you have to do. But it's usually teams of like 4 to 10, depending on the size of the boat.
Okay. Wow. So that brings us to containers, because I don't think all of the working containers you do by yourself either.
No, we have a lot of teams that we work with. Obviously, the container registry team that I work on at Microsoft for Azure Container Registry, the Microsoft Container Registry for all the software we distribute on behalf of Microsoft. Mm-hmm. And then, of course, all of the various services in Azure that run containers. And it's not just the Kubernetes service, it's container instances. We just launched some new services today with serverless and containers. So there's pretty much, if you think of how VMs change the world for virtualization, containers are changing the world around virtualization. So pretty much all the services in Azure are moving to containers for hosting users' code, right? So all of that gets pulled from a container registry. So we're kind of at the center of all of it. So it's pretty exciting just for what we do in Azure. But as we're doing with the Notary v2 project, it's not just about Azure. We needed to build a solution that would work across all clouds. Mm-hmm. It's not just because my personal view is registries are just a commoditization, right? Nobody makes money on registries. That's there to support the platform. We have customers that are all hybrid, cloud and on-prem. So we needed a solution that would span multiple cloud providers, and not just cloud providers, but on-prem projects. And also Microsoft ships software. We're a software company, not just a cloud. We want Windows and SQL to run in our competitors' cloud on-prem. So it was very important that these solutions were able to pull from MCR or Docker Hub and being able to be validated inside of AWS Docker, AWS Google, on-prem and so forth. So it was very important to have it as a standard in the industry that wasn't unique to Microsoft. So that brings us to all the work we're doing in the community around through OCI and CNCF, and really working hard to try to lift the container platform as a whole, by adding capabilities to registries so that they continue to evolve, just like everything else in CNCF, right? We want these services to continue to get better. I have a personal belief we shouldn't have to build lots of new storage services. We have some great ones already. So let's, instead of running yet more services that are difficult to manage from a security perspective, from a customer perspective, how many do they have to configure, and do they have the same features? We want to build those capabilities on the services they're already using. So that's the investments that we've been doing in registries as a standard across the industry.
Okay. And then you did mention Notary there for a second as a CNCF project. What is it specifically that Notary does, and what value does it add to container registries?
Yeah, no, it's so Notary was built around, and it started, I think it was 2015, through with Docker. Docker was trying to, had this Docker hub as the registry, and there are various orchestrators and the other parts, the client. And the idea is, if I'm pulling content from one place to another, I want to know it's still signed, it's still in the condition it was built by an entity you trust. So they had built Docker Content Trust on Notary v1. That's what we refer to it as, and or what the industry is. And it conceptually was the right thing, right? You signed the content, it was tamper resistant, and you knew that it was signed by an entity, and you can set up a key for that. So that was great. Over time, as we implemented it in Azure, and as the community started using the technologies, we realized that there was some fundamental flaws with it. It had trust on first use, which means that as soon as I pulled something, if I was able to intercept that key, then that was the one that came to my machine. Well, you're owned at that point. So that wasn't a great thing.
Okay.
The configuration of it was extremely complex from a usability. The key management was very complex from a usability. All of those things you could likely get around. But one of the main things is I want to be able to promote an image from registry 1 to registry 2, from a public registry to my private registry, from a private registry in the development environment to the staging to the production. Turns out the signatures were tied to location in Notary v1. It literally was designed so that it was locked to that, because that location was part of the identity. And that was really the Achilles heel that said, all right, this just is not a viable thing.
And so if I may ask, does that mean that I couldn't take an image that's on Docker Hub right now, that's a public image, and import that into my private registry? That wouldn't work with Notary v1?
You could import the image and it would come, but the signature wouldn't.
Okay, yeah, and that's the whole point of Notary.
Yeah. So that's kind of the idea is when I leave one place and go to another, I'm still Steve Lasker, right? It's not because I'm Steve Lasker because I'm stuck in location A. If I get on a plane and move somewhere else, I am still me. My identity is tied to me, not to my location. So that was the flaws. So we assembled a group back in, I think it was the summer of 2018 at KubeCon. And I'd been writing about this because, customers are always asking about this problem. Hey, how do I sign my images? Hey, I can use Docker Content Trust. We implemented it in ACR. But it doesn't meet our needs. Like, yes, we know. So we assembled a group around the community, across all the clouds, all the providers, projects, and said, look, let's get serious around trying to solve this. So we kicked it off in the end of 2019. AWS actually hosted it for us. We kind of coordinated. AWS hosted it, and it was just an awesome event where it was a who's who of registries and projects. And we kicked off Notary v2 to solve those core problems. We really wanted to make sure that we learned from v1, learn what customers and users were trying to accomplish, and spent a number of months just identifying what the goals and requirements are. I like to joke, there's lots of great designs. There's lots, I use an analogy, there's drawbridges, there's suspension bridges, there's tunnels, and all of them are great designs, but for which problem are you trying to solve?
Yep.
So we really wanted to make sure we were designing a solution for the problems that our users were having. And that was, one of them was the promotion of content across registries.
Okay. And so what does this look like in practice? Like, how does Notary solve this problem?
Yeah, so this is the other interesting aspect is, one of the side challenges of Notary v1 is it required another service to be run. It ran as a sidecar service, which users, who cares? But it required registries to run this fairly complex code, and it had these usability problems. If you pulled a tag with Docker Content Trust on, it came from one location. If you didn't have Docker Content Trust turned on and you pulled the same tag, the string, you'd get a different piece of data back. So So what we said was, look, we need to make sure that this is not unique. Like, we wanted to really minimize the changes a registry would have to run. And we also recognized that the more we design this pattern, that signatures need to be separable objects. We wanted to make sure that you can validate a signature without pulling the content. Right? If I go into an airport, in fact, this is one of the things that I like showing. Let me show this this piece here. So if you can do a little screen sharing.
Yep, we can see your screen.
All right, cool. So if I'm going to the airport, when we used to do this, I walk in and there's a TSA agent, and they're like, whoa, hold on. Who are you? Where are you going? Right? I'm outside of the secured staging area.
And Steve, sorry to interrupt you here. Just for our international audience who doesn't know what TSA is, TSA in the US is the Transportation Safety Association, who basically checks your identity card and your boarding pass before you're allowed to get into the secure area of the airport.
Thank you. Because TSAs are also timestamp services, timestamp agent authorities. So yes. So we walk up to the airport. There's an agent there. There's a person there. It says, "Where are you going? Who are you?" And I give it a pod spec that says, "I'm trying to board this plane." Right. So, and they're like, "Great. Okay, fine. But who are you?" And I provide them an identity. I say, "Hey, I'm Steve Lasker." And they're like, "Okay, is that a note from your parents? Like, who says that you are valid to be this?" So in the US, there's 50 states. There's actually this interesting thing going around called Real ID. So maybe not all 50 states are considered valid. Certainly all countries may not be considered valid if I gave them a passport. Like, that's a passport from a country we don't trust, so you're not allowed in.
No.
So there's a list of those entities that they decide you are trustworthy. And it doesn't matter whether it's digital or not. And then they stamp it, like, "Hey, you are, approved to go in." So there's a second signature. You can say my identity is a signature. The agent then puts a second signature that says, "All right, Agent 99 has stamped you and you are allowed into the staging area." By the way, I got scanned, right? Another interesting thing about how we scan container images for the current state. But so now I'm in the staging area and I've got this extra stamp. I have my original identity, but I have a TSA Agent 99 on it. And when I try to board the plane, there's another agent there who goes, whoa, hold on. You're not getting on the plane until you show me some document that says you're allowed. So again, I provide them that pod spec digitally or analog in this case, but you get the idea. And Agent 44 isn't asking me, am I Steve Lasker, what state and passport and so forth. They're looking for a stamp that says, were you allowed in the staging area? If you're allowed in the staging area, then I don't really care how you got there. Somebody already approved that. So now there's a second signature on there. And that's the important aspect here. So Agent 44 says, okay, that signature is valid. There's no other pod specs that match you on the plane. There's no Steve Lasker sitting in 22F. So agent 44 will stamp with a third signature and then allow me on the plane. And now I'm in production with an agent 44 stamp. If that's the analogy. As you're promoting, you're giving it another signature that attests to that state. So we can, well, anyway, so that's how we've been thinking about it. And I can, if I had more time, I would explain, the other part. But I think maybe a demo would.
Yes,
some of this.
We love demos on the show.
All right, so let's do some demos here. Let me just pull up my demo scripts. So what we're going to do is promote this image, and I'm going to show this. It's a Wabbit Networks registry in the Azure Container Registry. This is live. It's in a dog food environment for now. We actually have all this working inside of Azure, and this is actually one of the first live demos I've done, showing it in Azure Container Registry. So that's pretty cool. So we're building and pushing the image. Nothing magic, right? That's this normal thing. Nothing's changed there.
Okay. So this is just a standard image with nothing special on it, and it's not signed yet.
Not signed, right? So now I've got this image in the registry, and there's no signing to it. So I do want to sign it. So I'm going to generate a certificate. I could have pulled this from Key Vault. We're just trying to keep it super simple here. Mm-hmm. So there's a Wabbit Networks IO key, and I can simply sign it. It's really that simple. I don't need any other extra services. We have an X509 cert that was issued within my company, however I want to manage those, which is what production environments have told us that that's what they need. Their crypto boards are very comfortable with X509. They manage those today. That's what they've asked for their production environments. So now it's signed. I've got my image signed. There's no additional components to it. And if I list,
if I may ask here, it also, signing the image doesn't seem to change the digest of the image.
Correct. So this was, thank you. That's a really important concept. When you've got your Helm chart, your pod spec, whatever it is that you've referenced your image with a tag or a digest, we didn't want to change any of those charts and that you are already set in production. Mm-hmm. All we wanted to do is add another validation layer on top of that says, all right, whoa, before you go into the production environment, before you board the plane, the Kubernetes plane, we just wanted to do an extra validation. And we wanted to yank that string out of the pod spec, out of the Helm chart, and ask the registry, do you have any signatures for this string? So there's this new concept of what references does a registry have to that deployment reference? And then I could say, well, by the way, give me the Notary v2 references for it. So I could tear off the signature, validate it before I ever deploy the image. So what I have here, and in fact, let's just take a look here. So hold that thought, because now I've signed the image, like you said, it's an extra one, and we'll, I just did that, sorry. Sorry. So I want to list the signatures, and if I try to verify, it's actually, the verification step is going to fail because I didn't tell it who I trust yet. Okay. One of the things we hear about is, the analyst will say, you must support signed images. Nothing can be deployed unless it's signed. Okay, signed by who? Right? Mm-hmm. You want it signed by the entities you trust. So at this point, I can't verify it because we didn't tell it who to trust. So what I'm going to do is configure the policy that says add the Wabbit Network cert to our policy. So if I look at that policy now, we can see the verification certs. Now I have a reference to that particular certificate. Okay. So now if I try to verify it, it passes because it does have a signature for the one that I've said works, right? It wasn't just the entry to the airport. It was the entry onto the plane, for instance. In this case, it is the entry to the airport.
Okay. And just to verify, all of what you're doing now is running on your local laptop. So basically, you're doing the signing and the verification locally, and you're not checking with an external source?
Oh, I see what you're getting at. So what we've done is, let's take a look at what's in the registry. So if I use this new command called ORES discover, ORAS knows how to ask the registry for references.
Mm-hmm.
When we did the sign, we actually pushed this Notary v2 signature as this artifact in the registry. And that was linked to the net monitor image.
Okay.
Now, to your point, what was done locally, when I said notation verify and I passed it the image, the notation verify command in this case, because I didn't say -- local, says, all right, hey, registry, do you have a Notary v2 image for, sorry, a Notary v2 signature for this image? So it pulled that signature local to verify, but it didn't pull the image.
Okay. Yeah. Okay. Then I'm with you. Sorry for the confusion there.
No, it's great because this is the whole interaction we're trying to make sure we've got of detachable signatures so I could verify them. And so you can see, here's the interesting part. This is an actual graph of objects. That's our V2, that's our container image.
Mm-hmm.
And then there's a hash of types. In this case, it's a Notary v2 type of signatures. And it gets more interesting because now if I show the tags for that net monitor image, what we're going to see is there's only one. Because the things that I want to interact with on that registry are the things that I've signed, or the things that I've deployed. The signatures are attributes.
Okay.
If I list the files on my machine, I don't get the attributes by default. I have to ask for them. So that's kind of the model that we wanted to do, is the attributes to a thing that I want to interact with is extra data. Don't pollute my list, because I would view that as a breaking change for all the experiences customers have around their list of tags.
Yeah, that makes sense. And then I don't know if I'm thinking one step ahead of you, but how do you verify those? How do you think about verifying those signatures as you pull the images into, let's say, an ACI or an AKS cluster? Do you verify them each time you pull the image, or how do you think about that?
Yeah, that's a great point. So in fact, I'm going to show that. So let's kind of go through some of those steps. So what I've got here is this is just showing the manifest listing in the registry. So you can see that, let's see, here's our container image, and there's our tag. And then here's our signature using the ORAS artifact manifest, and it's got a reference to that image. Okay. So the manifest is there. It's not using a tag because the registries have adopted this ORAS artifact spec to know how to establish these references. So let's do what you were just asking about. So let's clear this out. Now I've got this graph of content in the registry. Right now it's just one image, one signature. Let's say I want to promote it. So what we're going to do is let's pretend that we're going to clear out. So oops. Or PS, that's what I meant to say. So there's the only images I have in the registry is an instance of the CNCF registry. We're going to use that in a couple of minutes here. But there's nothing else up my sleeves, was kind of the point. If I go to an environment where I'm trying to import the image, now what I'm trying to basically simulate is this is a VM or a host node that has no knowledge of what's going on. I'm going to import that public image, and I want to bring it from Wabbit Networks into the Acme Rockets environment. I need an Acme Rockets key. I could have pulled it from Key Vault. I'll grab it from here. And if we look at our policy at this point, I have a signing key for Acme Rockets, but no verification.
Mm-hmm.
So just like before, verification fails. I'm going to sign that image with the Acme Rockets key. Let's assume that I've scanned it. I've run some tests on that image. I think, yep, that's good. I want to bring it into my environment. So I'm going to also configure that the Acme Rockets key is part of my verification list. So now I've got two signatures on that image. So here's our net monitor image. Notice the hash for this v2 signature, and I've got two signatures on it. One of them is the net monitor, one's the Wabbit Networks one.
Okay. Can I ask a question here? Just to frame my mind, do I think about it this way that let's say I'm starting off from an Alpine image, I would trust the let's say the public cert of that image. When I pull that in, I would then do some scanning to make sure that it comply in my CI pipeline. I would do some scanning and then add my own private stamp to it so other processes in my company can use it but don't have to trust the public cert.
Exactly. So we really believe in the promotion of public content into private registries, not just because you're not worried about the reliability of all the connections to the public internet, not just because you want to lock down the VNet to any public endpoints, but these updates that happen upstream are usually good intentions.
Mm-hmm.
Sometimes we're humans and make mistakes, so we don't want mistakes to get pulled in automatically. We want to make sure it's a very deliberate process that when an update is made upstream, companies can look at it, evaluate it, make sure that the updates match their security profile, make sure it matches the functionality, and then import that public image update into their environment. And to your exact point, they want to stamp it with a signature of their own. So now everybody inside their company is going to make sure that they're signed with Agent 99 signature, not some one of 8 or 10 or other public endpoints that somebody else is managing.
Yep.
They look at an internal library, that's the ones that they trust. And in this case, so you can see that would have the external signature and the internal signature. And now internally, I don't care about the external signatures.
Yep.
I only care about, is this stamped by my company process?
Yeah, I'm with you.
So let's go a little bit further. Let's say that there's SBOMs. And actually, I'm going to create a real simple SBOM.
What's an SBOM?
Thank you for keeping me honest. Software bill of materials, or I think some are calling it a system bill of materials because they want to make sure that it handles hardware devices as well.
Okay.
So it's literally just a inventory of, if you look at the side of the box of food, it lists what's in your food. And it's not, it's really evaluated at the time of build. So it's the ingredients. And now I could see what packages it includes, what were the compiler flags that were set. So I can see that information related to the software I'm trying to consume.
Okay.
But where are you going to get that SBOM from? I got my image from the registry one. Do I have to go off to some other random place to find it? What we realized in building Notary is if we can assign attached signatures to an image and the registry doesn't need to know it's a signature, why can't we attach other things? So here, what I did is I pushed this SBOM JSON file to this repo, the NetMonitor repo. I linked it to the subject is the container image.
Mm-hmm.
So, and I'm going to sign it as well. Let me get the digest of the thing I just pushed, that SBOM I just pushed. I'll sign it. Now let's take a look at the graph of objects I've got in the registry now. So now, in addition to the two signatures, that I have for the NetMonitor image, I also have an SBOM. That's the manifest for the SBOM that references the blob that we just pushed in for the JSON. And then here's a signature on that same SBOM. So if we look, there's a rich graph of objects starting to build here. And
Yes.
Each of those are terrible artifacts that I can go independently pull.
But all of those objects, the signature and the SBOM are, let's say, linked to your container image.
Yep.
But if you have a team or a piece of software that doesn't care about the images or the SBOM, they can still pull in the container image as if that wasn't there.
Exactly. If they don't care, they can separate them. Or if they do care, this is what I call the Trojan horse scenario. How do attack vectors happen? I have a way to execute code, and then I get code on the machine. If I ask a host to verify or deploy an image, and it's signed by Evil Co,
Mm-hmm.
if the signature was embedded in the container image, let's say as a layer, then the only way I can verify that signature is to pull the image to the machine, try to verify the signature. It sees that it's bad code, goes, oh, I don't want to allow this. But the content is already on the machine. So now that other exploit can go read that layer content, even though it was said, no, this shouldn't be bad. This shouldn't be good. I shouldn't have to create more security or put me in an isolation booth on the machine. Don't pull the content until the signature was validated. Just like when you're at the airport, you give them your ID through the little hole, and only after they validate you are you allowed to go in.
Yep.
So it's the same model.
Yep. Makes sense.
So I know let me run ahead with one thing. So let me show you a richer graph of content. Let's say I'm going to scan the image and I want to save those scan results. So I'm using SNCC because it comes as part of the Docker CLI. I can see that information is there. I'm also going to push that to the registry. And I'm going to say I'm going to sign the scan results as well. So if I look, now my graph has gotten really rich. So now I have the container image, 2 signatures, an SBOM, which is signed, a scan result, which is signed. Right? I'm starting to get all this information, and it's stored together on that public registry, so I can pull in as much or as little as I want. So that's the really cool part of it. And to what you were saying before, let's say I want to filter the types. This is the full graph that's on the registry. I just said, hey, can you filter on the artifact type of a Notary V2 signature? Yeah, no problem. There you go. So now if I wanted to promote that into my registry, I can choose the entire graph, or I can do a filter. And the model here, and why it's important for registries to have this up-level capability of references, it's not just we want to make sure that people can delete the content in the registry when they want, right? If I delete the net monitor image, all the other stuff should go with it. It's that I also want to be able to use generic tools. If I have a bunch of files in a directory, do I use PowerPoint to copy the files to another directory, and Word and Golang? And, of course, that's just silly. I use a file API. This is copy the stuff from here to there, whatever. So that's what we've done here. Let's take a look. I have a private registry. There's no repositories in it. What I'm going to do, and I've got this ORAS copy. I think that's what it was. That's an early build of this. What I want to do is copy that entire graph into that private registry. So now when I look at the private registry, there's one repository, net monitor. There's one tag. But if I look at the graph, whoop, I didn't mean to filter there. Actually, hold on. ORAS discover -o tree. In my private registry, I just copied this entire graph. Okay. So anyway, that's kind of really the richness that we want to be with. Here is ORAS as a registry standard client. It doesn't know any of these types. Because the registry has this rich metadata to understand those references, we can now use it to copy the content straight across.
Okay, cool.
So, anyway, that's kind of the, and all of this is real. It's running in Azure. We believe through the Notary project, we wanted to innovate the entire platform. This wasn't just how do we do signatures and do it in a way that, we wanted to make sure that this was done for the long term through great innovations. It's through the work in Notary V2 that we recognize this generic pattern for doing reference types. So now we can store scan results and SBOMs and other things in registries. So that's kind of where we're at this point in the game.
And plus, what I wanted to say as well is this: you mentioned this is running in Azure, but I'll make an assumption that this can run in Google Cloud or in Amazon or in your own private data center as well.
Exactly. So this is what we talked about early at the beginning, right? We didn't want this to be unique to Azure. Our customers work across multiple clouds. They work on-prem, and Microsoft is a software company. We want to be able to support Windows and SQL and .NET and all the other products that we build on other registries and other clouds. So all of this is built under CNCF through the NORA's artifact spec. And we're working with various registries to adopt it so that we can, again, up-level the whole platform. AWS has committed to it. Docker Hub is committed to it. The Zot project has committed to it. So we're starting to see, this ecosystem kind of build and improve. So we're pretty excited about it.
And I think that's what I find so amazing about the cloud native and CNCF community is and the fact that you have all of this collaboration cross company boundaries. And it makes me think about something Kelsey Hightower tweeted yesterday: same team, different company.
Yeah, no, it's definitely, I think, some of these, they're built by individuals that happen to work for companies. And then we've got the great support of those companies to allocate their time to work on it. I've always been working on a lot of the open source stuff for ACR for the last several years, but all this Notary work and stuff that we're doing around the registry, ORA's work to improve the capabilities, it's pretty been most of my time these days.
Mm-hmm.
But that's what Azure and Microsoft support. So it's great that we're able to continue to invest in these things for the ecosystem as a whole, and work with a lot of great people, that are helping us get this done.
No, and it's not just about using it or supporting the standards. It's actually about contributing and helping build the standards cross boundaries.
Exactly. We ORA's is an open project. We've got a lot of great people helping with it. There's the distribution instance. So CNCF distribution is what backs a lot of the registries that people use today. So that's out there, and we're getting contributions there. It's really fun to see the power of everybody being able to contribute their efforts, their time, their thoughts to improve this as a whole.
Okay. Well, thanks for coming on today, Steve. I definitely learned a thing or two. I hadn't played around with Notary before, but it seems super interesting, and it's something I want to play around with and see what it can mean for customers. So thank you for coming on.
Yeah, no, thanks. And thank you for, reach out to us. We're on Slack. You can find us through the Notary Project on GitHub or notaryproject.dev. We're always looking for, more help, more assistance, more feedback. What is it, the problems that we should be, helping people solve? And then for people to help us solve them. That's the big part of this.
Yes, come help contribute.
Definitely. So,
cool.
And thanks for the opportunity to get on and talk with you.
Oh, you're welcome. But thanks, Steve. And for everybody tuning in, thanks for joining us today. And we'll see you again in about 2 weeks for our next episode. Thanks, everyone.
Thanks, folks.